Aluminum. It's the 13th element on the periodic table of elements. So this is Norris Teaches Science with me, Mr. Norris, another physical science edition of my video lecture series that I do in my classes. They take a little longer while the students copy the notes, but I digress. Today we're going to talk about classifications of elements. So the goal of this video is I can describe the structure of the atom and how the components are calculated. So, classifying elements. Before I begin, I hope you brought back your labeled periodic table because we're going to be highlighting a few things on it and labeling those. So, elements are classified as metals, nonmetals, or metalloids based off their properties and the location of them on the periodic table. Let's talk a little bit about metals. First off, most elements are metals. Most elements on the periodic table are metals. They're good conductors of heat and electricity. Most of them will allow heat to transfer with it. They also will allow electricity to transfer with it. They're solid at room temperature, most of them, except for mercury. Mercury is a metal, but it's liquid at room temperature. Mercury used to be used in thermometers, but it's no longer in general sense because mercury can cause mercury poisoning, and you can die from it. You get really messed up too from it, so don't mess with mercury. Ductile metals are ductile, which means we can turn it into a wire. They also have luster to them. Most of them can be shiny or be polished enough that they reflect light. They are malleable, which means we can hammer them into sheets or we can shape them with a hammer. They usually have a high melting point. It means you have to get their temperatures really high for them to melt from their solid form to their liquid form. They're on something called the left side of the stair step, and we're going to get to that stair step in a moment. You'll understand that. Just remember left side. Very important metal is known as francium. It is the most reactive metal on the periodic table, and they have high boiling points. That makes sense since they already have a high melting point as well. Nonmetals are kind of the opposite. They're dull, means that they're not always shiny. They are brittle at most times. They can break really easily. They're poor conductors of heat and electricity, means that heat and electricity do not transfer well with them. Most, not all, but most are gases at room temperature. They have a low melting point, so they don't have to be heated too far for them to turn into a liquid. And then you don't have to heat that much farther after that to have to the boiling point. Since most of them are gases at room temperature is about 75 degrees Fahrenheit, their boiling point has to be lower than that. They're on the right side of the stair step. We're about to get to the stair step. Just remember right side. And important nonmetal is fluorine, which is the most reactive nonmetal on the periodic table. Now, the stair step line, I mentioned it twice. Those are the metalloids. Metalloids have both characteristics of metals and nonmetals. Just depends on which metalloid it is, what they have. So who are the metalloids? They are boron, silicon, germanium, arsenic, Sb, Ti, Po, and At. Those are the metalloids. Very important to know where your metalloids are. And here's why. Hopefully you brought your periodic table back with you. I'm going to get purple. And you've already have labeled it. You should have your oxidation numbers up there. You should have your valence electron numbers up there. You should have your period numbers up there. What I want you to do, I want you to grab a highlighter. Hopefully you have one. And I want you to do a little highlight line and label it metalloids. I can't really write with the highlighting tool up here. And we're going to highlight our metalloids. So boron is a metalloid, silicon, germanium, arsenic, antimony, beryllium, polonium, and astatine. Those are your metalloids, and you see they form this little stair-step line. Aluminum is not a metalloid. Aluminum's a metal. It's one that it's really important that you understand that. Now, everything to the left of it are metals, except for hydrogen. Hydrogen's weird. Hydrogen is the only non-metal on the metal side. Everything to the left is metal. Everything to the right is non-metals. So let me get colors so you can see. All right. Everything that I'm doing in red, do not highlight these. These are metals. And everything highlighted in green are your non-metals. All right, but make sure you have your metalloids highlighted. Now, periodic trends. One trend you need to know about is reactivity. As you go left to right across a period, the less reactive elements get. Because when you get to the far right of the periodic table, those elements, they don't react. Going down a group, more reactive the elements become. I hope you learned something today. Come back again. Hopefully you're really learning how to use these periodic tables and understanding all the different components of it. But I'm Miss Norris, and I'm out for this video.